Good morning. How are you? Good. Yeah, I am streaming if you care about that. Do you care?
Oh, yeah.
People can hear this.
No.
Okay. What's up?
I wasn't asking a question.
Whoa! For today's assignment, you're supposed to have gone through the IDE assignment for your particular project language. So, what language is your project in for your team? You don't know? They haven't decided. What do you mean they haven't decided? That was supposed to be done before spring break. Yeah? Have you talked to your team? Well, that's probably the truth then, is not that they haven't decided. You just don't know what they decided. Better ask them. Because basically, depending on which of the 3 projects they picked from, that depends which assignment you have to do today.
Okay. No problem.
Okay?
No problem.
Yeah, let me know if you don't get it cleared up. I'll help you figure it out.
No problem.
Good morning, sir. How are you? I feel darker. Yeah, but not more than... No, like, I pushed the same button I always push, and I think these went out this time. Woo! First row just became the sleeper row. It's definitely darker. You mind playing cameraman? Can you play cameraman? Thanks, bud. Cool. Don't know what time it is. One more minute. Good morning. Good morning. I'm Tony Farrar from the Mechanical Engineering Department, and I like to make pretty pictures using code, which I'll show you how to do today. Thanks for being here. We are at the end of an exciting phase of the class. This week we're wrapping up what I would call the training montage. All right, so every great movie is the same story, right? There's some hero, i.e. Rocky or Luke Skywalker, or in this case, you, who's faced with a challenge. They then go into the training montage where they have to carry Yoda around or run up the steps, and eventually they're ready for their big challenge. One last week, and then the music stops and it's time to get in the ring, and we are going to start in on the projects, which is my absolute favorite time of the season. Semester, whatever. We're about to get super creative. You're about to see some shifts, obviously, in what the assignments look like, as well as what we do in class here to support you as you develop your projects. So, a couple more days of code here in class to get you nailed down on some of the nuances of programming, and then we're going to move into more of a support role for your projects. So, this is where you should be. The list keeps getting bigger, in case you haven't noticed. I can summarize it really easy for you. By Monday, a week from today, you should be done with modules 1 through 4. Every single assignment in every single module 1 through 4. That's the easy way to do it. If it's 1 through 4 and there's a link to it, go do it. If you're on track for things, that means this week you're working on core skills again. It's the same problems you've already solved. You're just translating your solution into the new language that you're using for your project. Yes.
For the core skills for Java, when you click on it, there's no core skills there for us to do.
Okay, we will check that. Seems like we might be missing an assignment. We'll check it. Java might be unclickable for some reason. We'll double check it. Let's make sure. Other questions? Yeah. So, turns out there's a little typo in the schedule. The assignment is due on Monday, but I said the cutoff for eligibility is Friday. Clearly there's an inconsistency there. So you've got 3 more days. What that means is, a week from today is the day. All this stuff is done. Every single assignment in every language, 70% or bigger, next Monday. Or what happens is your grade starts coming off because you can't work on a project. Unlike everything else we've done this semester, the project submissions have hard deadlines. They will be due on Mondays, no questions asked. And so you can't work on those if you haven't done these parts, because how could you possibly support your team effectively if you're not up to speed with the rest of them? So this is your opportunity and what I would consider your final invitation to get it in gear. Because on Monday, things start happening. If that scares you, we have support. Where can you go to get support? The engineering library. When can you go to the engineering library to get support? All day, every day that it's open, 9 to 5. In addition, except for the 1 hour we're in here, right? I don't think anybody's skipping class. But in addition to that, we have email support for you, codinghelp@temple.edu. And we are hiding out on every social platform, just waiting to answer you there. Depending on your question, you may get a faster answer in one of those places than others. But it is time, baby. Let's get it done. More questions? Remember, if you've done them in one language, you've pretty much done them in the second. It's just translation. Once you complete core skills demo in the first language, getting it into the second, also not so bad. Okay? We're Googling syntax here. So, Monday's the day. It's freaking me out. The clock in the back of the room hasn't been changed. Okay, that's all I have to say about that. Back to evaluating equations. This is a very engineering-y thing to do, so that's why I've been focused on it for a while. But it also has a lot of useful coding tricks for you, such as 1 and 2D arrays. What else did we do? We did looping, right? And we did functions. Last time I created some code and I used a function where it didn't really make sense because the function was only 1 line long. Today's the day. You're finally going to see why the heck I went to that extra trouble. So just to remind you, the 3 steps were to define the grid. Right? We used xmin, xmax, and the number of x's to do that. We created an even number of divisions. After that, we initialized the solution. Unlike working in something like Excel, you have to ask the computer to reserve some memory for you. And so, first we created empty arrays or arrays filled with zeros, and then we can start doing something with them, which is calculating the solution. And the way we did that was by looping through our x and y grids or our x grids or whichever it is, and one by one plugging values in to our matrix. So this is what it looked like. We set the limits, we set the number of x's, we had to calculate dx. You did this on Friday for your code sprint, and then we can use commands like this to kind of shorten the creation, but really what this is doing is it's appending and creating and filling with values all at the same time. So it's just a really compact way of doing all these things that you learned how to do separately. We initialized the solution by creating a big empty box where every column corresponded to an x value and every row corresponded to a y value. To do this in Python, we could also do this in one line, because what you can see is that this array could be thought of as an array that is filled with arrays. A little bit of array inception here. And so this is the code from one array creation, right? That creates a zero-filled array of size nx. And then we do that whole thing for size ny. And so every time this runs through one of its loops internally, it just adds another row to this array. So that's what we did there. And then we calculated the solution. So I did this in 2 steps, if you remember. The first thing I did was I created this function up above, and then after I built all my arrays and things like that, I could just run a nested set of loops to go through every value of I and j, which correspond to every value of x and y. And I could call this function for one value of x and one value of y, like so. And that's kind of where we ended up last time. So today, the first thing I would like to show you is how we've been reinventing the wheel. Hiding out on the internet are all kinds of libraries, which basically are pre-built codes that you can import and use. So it's kind of like functions, except they're already written for you. You just have to start using them. So for example, to create a thing filled with x's that starts at x min, ends at x max, and takes an even number of steps, it took us this line of code and this line of code, but it also took us like 3 days of getting smart before we could even do that, because what this represents is a for loop. It's got dot appends built into it and all kinds of things. There's a library out there called NumPy, and if you import this library, you can turn all of this into these 2 lines of code. It just knows already how to do that. Linspace, linear spacing between points. Xmin, start value. Xmax, stop value. Number of x's, end value. And it does all of this stuff for you and sticks it in an array called x because I've got my equal sign right there. Same story for y. And so these built-in libraries, built-in functions can be really helpful for streamlining the code, but also allowing you to think about your project on a logical basis and then go find out if somebody else has already written that particular bit of code and just borrow it. This was relatively simple, where we taught Python how to fill an array with evenly spaced numbers, right? Imagine if we wanted to teach Python how to draw a picture. How many more steps that would take? Well, thankfully, there's a built-in graphics library that we can just go use, so we don't have to teach it how to draw pictures. I'll show you that one later. For now, I want to show you how we can update the code we wrote last time using the NumPy library. So this is just the code from last time. I added a few comments to make it more readable for you. But you'll see here I defined my grid. I built the x's and y's. I built z. And then I did my nested set of for loops. I added this little print here to act as a progress monitor so that we could see what our code was doing. And then we added this distance to origin call where we evaluate z at each place and we store it in our array and print it. So this is the code we wrote last time. Fonts are still good in the back, I think. Thumbs up, thumbs down. Can you read this? Thumbs are up. Cool. And so if I run this right now, it works. Run module. And you can see here it's running through all the values of I and j there. That's what that little progress monitor does. It's just printing I and j. That's this command right here at the bottom of your screen. And then when it's all done, it printed this out. And obviously, it gave us a bunch of numbers because I didn't use any rounding. But now what I want to do is simplify this using NumPy. So The first thing you have to do is install this package called NumPy if you haven't done that. The easiest way to do it is from within the editor that you're using. You would run these 2 lines of code. For some reason, when you run it from within the editors, it takes a while. So I actually had to run this overnight to get my computer to do it. So it might be something you do before you go to bed rather than right now as you're feeling inspired. But either way, once that's done, we'll now have this library called NumPy. And so the way that you use a command from a library is that you import it. So like NumPy, like that, and now NumPy's commands just came in. To access the built-in commands, we'd have to open up the documentation on NumPy to find what those commands are. And the way we would run a command would be something like NumPy dot linspace. So linspace is the command, and then I could type things like xmin, xmax, and nx, and now linspace would work. It gets a little annoying to type out the word NumPy every single time because it's kind of a long word. So we can use an abbreviation. If I say import NumPy as np, I can change this line to just np.linspace. Saves me a few characters, lets me be a little bit lazier as I type my code. So we're going to do that. But that's what that as does. It just adds the ability to use NumPy, but simpler. So let's just go right down the code and translate. Things that NumPy knows how to do. NumPy knows how to do a square root. So I can comment this out and replace it with return numpy dot square root of x squared plus y squared. Remember before we had to trick it into doing it using the power to the 1/2. Now I can use the built-in square root function, and it just knows how to do that. Okay, we come down here when we get to clean up a little bit. Before, we had to do this dx calculation and this x with all these loops. Now I can just type x is equal to numpy dot linspace, linear space from xmin to xmax using nx points. Questions on that? We okay? Same story here. I can do this again for dy. So now y is equal to np dot linspace ymin, y max, nx. So it saves me a couple of lines there. And it saves me from having to think through the logic. Imagine if instead of having a linear spaced one, I wanted to do something on an exponential distribution. It has one of those built too. Did I make a typo? Yeah, I did. NY. Okay, up, NY. Just NY. This Z business can be replaced with a nice and easy function, also borrowed from NumPy. So I can make Z equal to numpy dot zeros nx ny. What do you think that does? Oh, and for some reason we have to put hard brackets in here, so I'll do that. What do you think the zeros command does if I give it nx by ny? Not tricking you. What's that? How many zeros? How many zeros is it creating? Yeah. Cool. So it's going to make a 2D array, nx by ny are its dimensions, and every single box in there is going to be pre-filled with a 0 for us. And if you don't believe me, I'll just come right here and write print z to prove it. And so let me run this really quick. And there's the, before the counter started here. Well, now we got to wait for that to go again. Jeopardy music. Done. Okay. So there it is getting printed at the beginning. And one of the things you'll notice is that once NumPy is opened up and you use things like arrays, it prints them a little bit prettier. Remember before it just kind of printed a list of lists and it was wrapped from row to row? If you don't, it looked like this. So there's the break from one row to the next. Now it does this nice wrapping format for you so you can see it as a 2D array easier. Thanks, NumPy. The only other thing, this is, we can do it or we can't, doesn't really matter, but it lets us use indexing like this instead of 2 brackets on arrays. Not really sure about the pros and cons on this, other than to say this is closer to things like MATLAB, if you happen to be heading to that language at some point in your life. So you can index it either way and it still works. And so this will run. And so we dropped out a couple commands, made things a little bit simpler. And you can see there that I also added a progress monitor here. It's a little crude, but it tells me I's and J's, so that way I know when this thing's done. But it also, by the way, is kind of instructive in what this thing's doing. I and J are our indexes, right? And so in this nested loop, I clicks over and then we run through all the J's. And then I clicks over again and we run through all the J's again. So watch the numbers here and see the pattern. I is 0, then I is 1, then I is 2, 3, 4, 5, 6. And you can see in the right column what J's up to. And so we're going through every combination of I and J and doing the math that this calls. So we're going through every value of X and every value of Y, calculating a value of Z, and sticking it into the corresponding spot. If I had rounded so this fit on lines, it still would have printed pretty, or if I had a really wide monitor. Okay. So that's one library that we can start borrowing from. If you remember, I wanted to make this Mandelbrot fractal, and what I want to show you now is the power of using functions, because I'm only going to have to change a couple of lines to get this, instead of doing distance to origin, which is the function we wrote last time, now I'm going to make it do Mandelbrot. Just for your edification, I'm going to close this and open up a new file here. This is because I want to be able to print all of the different increments we went through today, or upload them for you. I've added comments in so you can read them. The thing that we're going to work on right now is writing a function that does this Mandelbrot algorithm, which was just a little bit more complicated algorithm. Remember, we're going to take a value of X and Y. We set those as X and Y new. And then we run through this loop where we continually calculate these two lines until either it blows up or we hit the max number of times we're willing to run that loop. So I know this is kind of going back in your dusty memories a little bit, but it's just a different bit of math. Right? Before, we did this math, square root, which is just telling us the distance between the origin and our point xy. Now, we're going to define the Mandelbrot algorithm. I've already copied the comments in here for you so that we can kind of do this a bit more quickly. But if I want to define a new function, I'd type a word like def, and I could do Mandelbrot algorithm, and it's going to have some parameters that will pass it, but we can discover what those are as we get going. If I want to make x old equal to 0, how do I do that? If I want to define a new variable called x old and set it equal to 0, what do I do? Reluctance to participate or totally lost? Yeah. Cool. X old equals 0. If I wanted to find something called y old and set it equal to 0, what would I do? Huh? Same thing. Y old equals 0. And if I want to set z equal to 0, hey, we're catching on, all right. And we want to calculate our new based on x0 and y0. And so I can just translate as I go, something like R new equals, let's see, I want to make sure I got my, I stopped using these underscores. The underscores were in the pseudocode. I want you to see that I'm changing something here. How do I do a power of 2 in Python? Star star plus y0 star star 2. Okay. Now we need to make this while loop work. So we type the word while. And I want two things to be true, and I can just type them both out. I want R new to be less than R. That's the passed in command. And I want Z to be less than our max number of iterations N. How do I make this work? What's missing? Yeah? Right here. Yeah, so I used, that might be a little confusing, I guess, huh? Yeah, we can change it. So let's do that. X underscore old, Y underscore old, R underscore new, X underscore 0, Y underscore 0. So these are just comments, and this is actual code. We'll make them match, it's better. R underscore new, okay. Now we run into inconsistencies because changed cases on you here. That's okay. So we just need to type these equations in now. So we can do X new is equal to X underscore old star star 2 minus Y old star star 2 plus X underscore 0. Theories on what Y new is going to look like. Pretty similar. Y new is equal to 2 times X old times Y old plus Y 0, just translating these equations into Python. Now remember, because this is iterative, we want to take those new values and use them to overwrite the old values so that the next time through the loop, they're what show up on this side of the equation. That's that recursive part of this algorithm. And so all we have to do for that is now say that X old is equal to X new, and it takes the value that we calculated here and sticks it in there. And we do the same thing for Y. Y old is equal to Y new. And now we need to check if R is less than R new. Well, in order to do that, we got to calculate R, right? So we'll do R new is equal to, how do we calculate a radius? Distance to origin of a point. Square root of x squared plus y squared works for me. So we could do x new star star 2 plus y new star star 2 like that. And I'm just going to skip the square root because we don't need to as long as I type r in as r squared. And finally, we want to increase our counter by 1. And there's all of that. So now I've created a function. I better give it some arguments. What's it need to know? Well, it creates x, y, and z. It didn't create x0 or y0, so we better teach it what those are. x0, y0. What else didn't we teach this thing? Huh? I heard it. As I read through here, okay, I've never defined x0 and y0, so I have to pass those in. What else haven't I passed in? Let's see, I create r new inside the function, so that one's okay. Where do I define r? The answer is I don't, and so it needs to become an input parameter r. And there's one more. Yeah, right? N's never defined anywhere because that's a user command. So I could type N, R, doesn't really matter the order, but that's the order I did it, so there they are. If the details of this function are confusing to you, you can think of them as just a fancy version of the distance to origin function we already wrote. And that's kind of the neat, sneaky trick, because now this almost works. What's missing from this function? What's missing from this function? Huh? Print? Well, we don't want to print, but we do want to get the value back to the reality, so we got to return it. Return z, and you'll notice that I want that indented once because everything inside the function is indented once. The second indentation is reserved for stuff that happens inside of our while loop. And so I return z. Now my function is complete. The only thing that wasn't in our original code, right? Here's our grid, here's our linspace that we already created from last time, the zeros, and here we are looping through everything, right? This is all the code we did last time. The only thing that's missing from here is that we've got some new controls to set, right? One is we want the radius to equal 4. Remember, we want it to be 2, but I'm going to make it 4 so I don't have to keep doing that square root, which just wastes a calculation. And we need the number of iterations. I'll just set it equal to something like 100. What we'll play with in a little while is you'll see that that number dictates how many different color levels we're going to be able to get out of our figure from Mandelbrot, because there's 100 now possible answers. Okay, so there's our window. There's our window. What's this going to do if I run it? I'm sorry? It's going to print z, and what's going to be sitting inside of z? I'm sorry? So inside of each element zij, we stuck this value of z in there. And what's that value going to look like as it sits right now? Yeah. The distance to the origin. So the last thing I have to do is update which calculation I'm doing. And so this is where we would call our function. So now we want z to be equal to, and I can never remember what the heck I did, so I just come right up here and I borrow this definition of my new function and I scroll right on down and I paste it. And now I've got all my inputs set. The only difference is I've got a little bit of translation. I called NN and I called RR out here in the real world. But x0 and y0 I actually just called x and y. So I need x of I and y of what? J. And now if I save this and I run it, barring any typos, whoo, where'd I mess up? What's missing? Huh? A colon. Caught on camera. Boom. So now it's running. That's a good sign. Only this time what we will hope we'll find is something that looks more like the Mandelbrot set instead of just distance to the origin. So it gets through. It's 11 by 11. And if you cross your eyes and let them go blurry a little bit, you can kind of see the numbers here look like that bulb that I showed you the picture of a few weeks ago. Obviously, we could graph this and really look at it, and that'd probably be more effective. So the only thing I changed there was I wrote a new function for how we calculate z. How'd I do? We all right? All right, so once again, because I want to show you this in stages, I've already coded that with comments. Here it is so I can post it. Now what I'd like to do finally is instead of just getting numbers out of it, I would like very much to be able to show you a pretty picture. So let's do that. One option would be to kludge together my own instructions on how to draw pictures. The other would be to borrow another already existing library called PyPlot. And I'm going to import it as PLT so I don't have to type the word PyPlot every time I want to use it. Same story, you have to install this before you can use it. But once you've installed it and it's on your computer, away it goes. So I've added a new command called PyPlot. Nothing in this code has changed, other than I now have the ability to run some plots. So all of this is the same as it was just a minute ago, so I'm just going to scroll right down to the bottom. And the only way that we've been visualizing our final array is with this print z command. So I want to show you two different options for plotting today. The first is just a standard XY plot. So for example, I can do PLT. Remember, that's referring to the package that I borrowed this from. Dot. Now, one of the built-in commands to PyPlot is the word plot. And in there, you give it values for x and values for y. And so if I run this, it creates a new thing called a plot object. And I can look at that plot object by typing plot.show. That command causes this plot object to appear. So let me run it and just show you what it did. Ruh-roh. What have I typed wrong? Oh, look at that. Wrong name of the module there. It's actually called matplotlib. What did I do here? There we go. So matplotlib has a lot of stuff in it. Good rule of thumb is they also have sub-packages like .pyplot, which is a sub-library in the big matplotlib. The less you import, the better, because you keep your file smaller and there are all these extra commands floating around that you're not using. So matplotlib is the big library. PyPlot is the sub-library of that. Caught. All right. Run this again. Now hopefully my XY thing works. Okay, well, it's calculating. That's a good sign. Cue the Jeopardy music for the second time. And boom! Imagine if I had to write the code to teach Python how to do this. Dear Python, I would like you to create a window. It's going to have little X buttons on top. It's going to be called figure 1. Draw a box that starts at this pixel location, goes this far, goes up, goes left, and goes down. And we're going to start typing some graphics on here. We better make those evenly distributed, dear Python. I want 2 significant digits to display. I want a little dash there to show where it goes. Oh, and then once you're done with all of that, I'd like you to take my XY points, play connect the dot, and draw them as a continuous curve rather than just dots, right? I only had 11 points. So what I should be looking at right now are some dots, but instead what I see is a line. That would be a lot to teach Python how to do. Thankfully, somebody else has already done it, and they've added some features to it, like this is now an interactive box. I can click on the little zoom, and I could draw a rectangle and zoom in. That's kind of cool. Didn't have to teach it that function. I could keep zooming in until you see nothing. Let's see, I bet if I push this button, it brings it back. Nope, that's the pan button. I don't know how to zoom out. Maybe the home button. Oh, look at that. One of the neat things you can do with this plot command is that it has extra arguments that are optional. So let's just see here real quick. PyPlot plot. And if I pull the documentation up on this thing, it gives plot XY format. Ooh, format, that's interesting. What can I do to the format? I wonder if this works exactly the way I hope it will. Yep, it does. So the format is a string. See the quotes here? Let's make this bigger so you can read it. Can you read that? Format looks like color, marker, line. So for example, here are my options for color. Here are my options for marker. And here are my options for line. So let's just mess with that a little bit here. I could make it color green. I could use a marker that looks like a, what do you want to do? How about a circle? And I want it to have a dash dot line style. Dash dot. Close that. Save it. And run. I gotta wait a minute for this thing to count. Hopefully you're starting to get tired of how slow this thing moves. That's intentional. I'm about to show you another neat trick. Hey, look at that. Green circles with a dash dot line connecting them. So now all of a sudden this unlocks a lot of options, right? You can take your data and start visualizing it. We don't want to look at X and Y. It's certainly not like this. What we wanted to look at was a two-dimensional representation of our Z matrix. There's a trick called p-color, which stands for pixel color, basically. And all I need to do is drop Z in there, and then once again, show the plot. Save this. And now what it's going to do is it's going to use the values of Z to color each pixel on this image. So let us watch this thing run one more time. And then I'm going to show you some really hacker stuff. We're going to go to the command line. What? Oh no, what have I done? Look at that. It's called PLT, not PLOT. Error there. Now we have to watch it run again. What you're observing right now, by the way, is the fact that when you run things from within an IDE like this, oh, hey, look, there's my Mandelbrot set. Now it's upside down, but you can see this bulbous thing is starting to look like that black and white blobby thing I showed you, but on its side. I was hoping for a round of applause there, but that's okay. So, when you run things from within the editor like this, what you end up doing is taking a long time to do it because there's so much overhead associated with the editor. When you press run, what the editor has to do is go and translate all your lines of code into instructions, and then it's got this extra memory hog sitting here. And so it just takes a while. And so what I'd like to do now is show you another way to run this. This file, this .py file, is sitting right here on my computer as Mandelbrot08.py. I don't know if I can make this, I can't zoom this, unfortunately. Sorry, back row. But you can see it's just sitting in a folder. So what I can do is bring up the terminal. On a Mac, this is called terminal. On Windows, I think it's called command line. And on Unix, it's usually called bash, because it makes you want to bash your head against things. I want to teach you a couple of commands. The first one I want to teach you when you get to the command line is a thing called ls. Probably stands for something. I pretend it says look here, because it tells you all the folders that you're currently sitting at. This is just a folder on my computer, and inside it are all these folders. If I type cd, that stands for change directory. So I can go cd, and then I could type, I just know the file already is sitting in Dropbox, like so. And now I'm sitting in Dropbox. You'll see that it added it right there. And if I do ls again, it shows me all my folders. Starts to get a little irritating. Check this stuff out. If I type cd, and I know, for example, it's in teaching, if I type TEA and tab up, not yet, because TEA stands for teaching and team. But if I get to that level, I can hit tab and it auto-completes it for me. That's handy. And ls again, and cd courses. If I want spaces, they look like this. Slash is going the other way. Oh, so much stuff. Look at that, I misspelled lecture. Lecoutre. Lecutre. Lecutra. I don't know. It sounds like something you'd see on a restaurant menu. All right, and now we're sitting here looking at this stuff. Fantastic, because now what I can do is type Python Mandelbrot 08.py. Oh, and it ran that fast. There's my graphic again. Used a little different coloring scheme, but there it is. You can see that it did actually print all that crap again, but you can see how much faster it ran, which buys us the ability to do something like, I don't know, make it more detailed. So for example, what if instead of 11 by 11, I wanted this thing to be 101 by 101? How much longer do you think it's going to take to do that? How much did I increase the computational cost of my program by going from 11 to 101? Something like an n squared, really, right? 81 times. So I changed it in there and I save it. And I come back here, and if you hit the up button, by the way, it brings back your last command. And I run this again. You can see here it's running through those iterations. So it's a little slower, right, because we did so many, but whoa! Now it's starting to look like a picture. Now I really was hoping for an applause. I'm joking. We could continue exploring this, right? We could make it 201 by 201. And now it'll run 200 by 200 and give us an even more detailed image. But you can see here there's a little bit of an irritation, right? If I handed this program to somebody that didn't have the open code in their editor, they wouldn't be able to play with it, right? Because to change this grid, what if I wanted to zoom in on a region, say? I would have to go into my code, change xmin, xmax, ymin, ymax, all that kind of stuff, right? Inside the code. Wouldn't it be neat if I could add those commands to the command line so that it would do it for me? First off, I wonder if there's no zoom button here for P color. Okay. So let me close that. And rather than typing this before your very eyes, I'm just going to show you how it works. Okay, so I'm going to close this one and show you my last version of this file, Mandelbrot 09. Okay. And what I've added here is a neat built-in library called sys, as in system library. And system library has this interesting container called argv. And if you type words on that command line or numbers on the command line after the initial command, every time it sees a space, it grabs that item, drops it into a new bucket in this argv thing, which is super handy because now I could tell people, okay, if you type nx, ny, n, xmin, xmax, ymin, ymax, ymax, I can access them. Well, what's that look like? Instead of, first off, where did I import that? Or didn't I? You know what? I'm just going to bring it up in my completed code. Let's, real quick. Like I said, not going to type this in front of you. So I import this. That was supposed to be ymax, a little typo. So I import this sys thing so that I can access sys.argv, and every element of that is just one of the words I typed after my command line. All the rest of this is the same. The difference is this. For example, if I say that the third element after the command contains a value n, then I can use that for n. This would throw an error if the user didn't type a number, so it's good to have a default. So for every one of these inputs, I put it in an if-else statement so that if the user didn't create this argument, there's a default value built in. So for example, there's a default value. Here I've done the same thing, right? I'm grabbing each of these to make xmin, xmax, ymin, ymax. Only here I create some default values just in case. And here's ny and nx, same story, default values just in case. I encourage you to download this and read it. Other than that, the code's the exact same. What this lets me do is, first off, if I run Mandelbrot 9, Mandelbrot 9, the default values with no inputs after this are 11 by 11, minus 2, that stuff. And so it'll run real quick and give me that grid. Okay? If, on the other hand, I wanted to, sorry, just trying to remember what the order was here. If I wanted to start specifying things, for example, I could say nx is 101, ny is 101. I want it to run 100 iterations. I'd like xmin to be minus 2, xmax to be 1, ymin to be minus 1, ymax to be 1. I could type those values just like that, and when I hit enter now, it uses those arguments for the control variables, and it ran the 100 by 100 case. And now's where things get neat, because we could, if we wanted to, start zooming. Maybe we'll keep the y limits the same, and we're going to go from, say, 0.25 to 0.5 on the x grid. And now it's going to zoom in just on that one region. And things got squished because I only zoomed in one direction. But you can see we're kind of looking at that crack at the back end there. We could refine y, say from minus 0.25 to 0.25, and run it again. And you can see how I've built the framework for something that lets us start to explore this, and I don't have to keep editing my code. And you can see there that as I zoom in, some of the more interesting swirly stuff is starting to show up. And so as you leave, let me just run this one more time, only I'm going to run it for 500 by 500 elements for the interested students to see. On Wednesday, more fun with coding, and then we will have ourselves an awesome week. Get it all done! Yeah, I heard that. There might not be an Android one either. As in... Okay, let me kill the stream here in a minute and we'll figure that out. Good morning.
I was doing the hacker